Assalamu alaikum. Welcome to this demonstration of complex engineering problem of course EEE 4705 microcontroller based system design, and our objective was to build a tic-tac-toe gaming device, and we've used Proteus for the hardware schematic, and we've used the MIDE 51 software, and we've written the program in assembly language. So I'm just going to go through the components one by one, and we were told to select appropriate input unit, and we've went with push buttons. We could have also used keypad, but we did not because push buttons are inexpensive and we can get it anywhere. And also each individual push buttons are connected separately. So if there is a fault in the circuitry, we can easily find out the fault. So that is why we have went with push buttons. And then for the output unit, we have used this LCD display here. This is a 20 by 4 LCD display. So we did not use single LEDs or 7-segment displays. We have used LCD displays because in this LCD display we can also show other texts that we need. So the push buttons are connected to different pins of the microcontroller. We can see that the 1 to 8 are connected to the pins 3.0 to pin 3.7. The 9 button is connected to pin 2.3, the mode button is connected to pin 2.4, and the reset button is connected to pin 2.5. And also we've added connections to the LCD display as well, and we've used the wireless connections because this just makes the schematic look a bit more cleaner. So we have connected ground to VSS, 5 volt to VDD, and this 5 volt is coming from this terminal here. So I've just made a common terminal and used that 5 volt throughout the circuit. So here we can see this is the 5 volt, 5 volt, 5 volt. Everything is supplied by this terminal here. Okay, and this is the contrast. This is for adjusting the contrast, and we can see this terminal is connected to a variable resistor, and the variable resistor is connected to ground and the 5 volt. And the other pins, the RS pin, the read write, the enable pin, are connected to the pin 2.0, pin 2.1, pin 2.2 of microcontroller. And the display, for display purposes, the D0 to D7 are connected to pin 1.0 to pin 1.7 here. So these are the D0 to D7, D0 to D7. We can see that in this way the LCD is connected. And also we have used a crystal oscillator of frequency 12 megahertz. So this is the 12 megahertz crystal oscillator, and I also added the reset circuitry. And for the push buttons, the terminals, the one terminal is connected to a pin of the microcontroller and the other terminal is connected to ground. Same goes for all the buttons. And I also wanted to use wireless connection for the push buttons, but I could not because Proteus was not allowing me to do that for some reason. If I had wireless connection here, it would not recognize it. So I had to put wires here. Otherwise, I would have much preferred to use the wireless connection here, and that would look much cleaner compared to this messy look. Alright, so I'm just going to demonstrate the tic-tac project for you, tic-tac-toe gaming device for you. So I'm just going to press on play. So here we can see tic-tac-toe mode, toggle, and B1 diff. So what does it mean? So basically we can also select the difficulty, and by default the difficulty is set to hard, and we can also change the mode. Currently the mode is PvAI because we were told to include two separate modes, PvP, player versus player, and PvAI, player versus AI mode. So currently it's selected as PvAI and difficulty is hard. So I'm just going to change the mode to PvP. So let's just press on this button. So now it will be changed to PvP, so mode PvP. So it's showing difficulty, but difficulty does not matter here. So I'm just going to start by pressing button 2 to 9. Any of the buttons will work to start the game. So let's press 5. So now player 1 turn X. So now let's say I want to put X on 5. So I'm just going to press button 5. So here I have X here. Now player 2 turn. So player 2 is going to place 0. So let's say I just want 0 to be placed on position 6. So I'm just going to press 6 and 0 is placed there. Now player 1 turn again, and I'm going to put an X on position 8. 2 turn again. Let us see what happens when player 1 wins. So I'm just going to let player 1 win. So I'm just going random value. Player 1 turn, and I'm going to, if I put an X on this value 2, then the game is over and player 1 would have won. So let's see what happens. So position 2, 3x. So player 1 has won, game is over. Player 1 X wins. Press reset button. Alright, so let's just explore the other modes. Now we're going to play with AI, and I'm going to just change the mode to PvAI. And after that, B1, that means button 1 will change the difficulty. Currently it's hard. So in hard mode, the AI will try to win. And there is an easy mode. In easy mode, the player, not the AI, the player will win. And there is a medium mode where there is 50% chance of winning and 50% chance of losing. So I'm just going to demonstrate the easy mode for you first, and then I'm going to show the different ones. So now the mode is set to PvAI, player versus AI, and the difficulty is easy. Alright, so let's begin. Now I'm going to place an X on position 1, let's say, and also this E indicates easy, the level. So I'm just going to press X. AI is thinking. AI will put 0. So it has put a 0 over here. I'm just going to place an X over 4. AI is thinking again. So it has put a 0 over here. So I have a clear-cut shot at winning by pressing 7. So now I've won and the game is over. And I have won against the AI in easy mode. Player 1, X wins. Press reset button. So I'm just going to press reset button again. So now I'm going to change the difficulty to medium. So I'm just pressing 1. Difficulty medium. So there's a 50-50 chance of winning and losing. So let's just see what happens. So let's say I want to press X on 5. Yeah, it's thinking. So it has put a 0 over here. So if I put X on position 1, let's see what happens. Also this M means medium difficulty. So it has put a 0 over here. So let's try to win by placing 9. So 9. I have won the game over here. The game is over. And player 1 wins. So now I'm going to play on hard difficulty. So I'm just going to change the difficulty. And now I'm going to start the game again. So here, now the AI will try to stop me as much as possible. So let's say I want to place an X on position 5. AI is thinking and it will choose the best possible move. So it has placed an 0 over here. So let's say I want to place X over 3. So should AI place a 0 over here? Maybe. So it has placed a 0 over here. So I'm just going to block it by placing an X over position 4. So position 4, I blocked it. And now let's see what it does. So now there is no way to, okay, actually there is, like position 2 and 8, but I think AI will block me. So let's say I want to put an X on position 8. So 8. Now it will block me on position 2. Let's say if it does. Yes, it did. Now only position 9 is left, but it doesn't matter because the game is already drawn. Position 9, nobody won. Game is over. The game is a draw. And it will say the game is a draw. So this is a draw. And now by pressing reset pin again, we can play again. Also one thing is that the program should show invalid move if I try to place a value where there is already an existing value. So let's try that too. So I'm just going to quickly go through it. difficulty medium, and I'm just going to start the game. And my turn is, let's say, 5. AI is thinking. And also the turn indication is there, so I know whose turn it is. It's now my turn, saying your turn. So let's say I want to place on 3, but before that, I want to see if the program can detect invalid moves. Now on position 2 and 5, there are already pre-existing values. So if I press 2, let's see what happens. Invalid move. And then if we press again on 5, it says invalid move. So now I have to press something else. So 5 is again invalid move. So now let's say I want to press on 3. So I'll place on 3, thinking. Let's see if it lets me win. Yes, I can win again. So yeah, the game is over again. So now we're going to move on to the code section and see how the code is working. So here is the whole code that is being used by Proteus. So I'm just going to go block by block and explain just a summary of what's happening. So in the startup block, so this is the first code to run on power up. Sets P1 and P2 low to prevent garbage reaching the LCD, and then sets P3 to FFH and uses um, set B on pin 2.3, 2.4 and 2.5 to activate the internal pull-up registers on all 11 buttons. So they read high on unpressed and low on pressed. So here, like, it was high when we uh, run the simulation, and when we press it, it becomes low because it's connected to the ground. So basically that is what is explained here. So this is basically the startup block. And then we have the mode selection screen. This is the main menu shown at the startup and after the every reset section occurs, and it clears the display and then writes all the 4 lines, the title line, the button instruction, the game mode, the PvP versus PvAI, and the line 4 tells the player which buttons to start the game. So this is the mode selection section, and then this is the game initialization section, and this is where it's the reset. It resets all game state for a new and fresh game and writes 00H to all the 9 board addresses through 38H individually, and then sets current player 01H so that it is X. 01 indicates X, so that X always goes first, and the game state to 00H for running, and move count to 00H. Move count matters for both draw detection and medium AI parity toggle. And now this is the main game loop. This is the central hub basically, and here the game returns after every move, and first it checks if it's an AI turn, and then what it does, if that both game mode must be 00H and current player must be 02H, and if either condition fails, it goes to the human path, and after either path there is a command called glapply. This glapply writes the chosen cell to the board RAM and increments the move count and calls the subroutine check win. So if the game is still running, it switches the current player and redraws the board and then loops back again. And if the game is over, it draws the final board and it writes game over in the display as we have seen before. And now there is the human move section. So this is blocked until a valid move is confirmed, and um, this is also this also has debounce and reads again to confirm and saves to the button validation level. Out of range values is restart the loop. For valid cells like 1 through 9, the board RAM address is read. If non-zero, the cell is occupied and invalid move is shown on line 4. Now the AI hard, the AI medium, and the AI easy part, basically explaining what's happening behind the scenes for 3 of the difficulties. So in AI hard, we have 5-level priority decision. It tries to win first. If it can't win, then it tries to block, then it tries to center, then it tries to corner, then it tries to put value on the side. So first it loads a 02 into R4 register and calls find thread subroutine to scan all 8 lines for 2 zeros and 1 empty cell, and if found, takes the winning cell immediately and it wins the game. And then the second one, it loads 01H into R4 and calls the find thread subroutine again, and now scanning for 2x and 1 empty cell. If it found, then blocks the player there. So basically it is the block operation, and in this way the rest of the code is made. So sometimes we'll try to center the value or corner the value or put values on the side, and this is the hard difficulty. For easy difficulty, the AI is deliberately dumb, and we can see that it deliberately puts zeros at random position, like in the worst way possible. It tries to put values on the sides first, like 02, 04, or 06, 08, very random values, and it lets the player win. And for the AI medium, this is just the combination of two, and it uses the move count as a toggle, and it masks the value with ANL and this command, and then this produces a strict alternating pattern. This produces an alternating pattern and one smart move and one dumb move. In this way, this medium difficulty works. And so this is the find thread subroutine. And then we also have the check win game state. So check win game state is basically where it is being evaluated if all the 8 winning lines are in the same line, and this pattern is found through the find thread subroutine, but it calls the do win level instead of do line level. So here this is basically the summary of that subroutine, and there is the draw board. And this cell, what happens here is that it positions the cursor at lines 1, 2, and 3 by sending the correct RAM address, DRAM address, and for each line calls P row 3. This is the P row 3 with R0 pointing to the first board cell of that row, and R1 holding the digit character for that cell. So this happens in this here. And there is the show turn. This section is used to show the turns, like this is the message your turn, message AI turn. This is shown over here. And then show result. This is the section where the result messages are shown. Message AI wins, message X wins. All these messages are defined in the end of the program. And this is the read button. And this is a wait relay and debounce. We have waited for 20 milliseconds due to the debouncing, because we don't want any values to be mistakenly taken into consideration. And there are all the strings, all the commands: player 2 wins, player reset button, AI thinking, current mode, hit any key to start. So basically this is the whole code, and with which we've generated a hex file, and we've used that hex file in the Proteus software, and then we've made this hardware schematic. So that was all. Thank you.